Welcome to Maths Lab. Today we are going to look at the topic number bases. Okay, and what we are going to do today is we are going to start from the beginning. So if you are subscribing to this channel, you will never regret why you subscribe to this channel. So do well to hit the subscription button so that anytime we drop our video, you can always be notified. Thank you. So let's start with the definition of a number base. Okay, we have said that if you have a number in base x, all right, then it is made up of integers from 0 to x minus 1. That is to say that the highest digits of any number base is always 1 less than the base. So what do we mean by that? We said that that a number in base x is made up of integers. It's made up of integers from 0 to x minus 1. Okay. For instance, if you are dealing with base 10, if you have base 10, then you can only have numbers that ranges from 0 to 9. Okay. This is always the reason whenever you're adding normal addition of numbers in base 10, because we generally work in base 10. If you have a number like, let's say, 5 plus 6, that will be 11. You're not going to write the 11 right there. If you're writing 1, and then you carry 1 to the next line. The reason is you are going to say 11 divided by 10 is going to be 1, remainder 1. Okay, so it is that remainder that you always put down and then carry the result. So that is the meaning of that here. If you are working in base 7, you can only have numbers from 0 to 6. Okay, if you are working in base 5, okay, you can only have integers from 0 to 4. From 0 to 4. And then what if you are working in base 2? Base 2 is otherwise known as the binary. Okay, here you can only have numbers ranging from 0 to 1. So from our own definition, we have said that the highest digit of any number base is always 1 less than the base. So you can always see that by working in base 2, you have 1 less than the base, which is you have from 0 to 1. Working in base 5, you have from 0 to 4. Working in base 7, from 0 to 6. Working in base 10, from 0 to 9. If you observe the series, you can always see that it is always 1 less than the base. Okay, so I'm going to solve 1 or 2 examples. Okay, let me solve 3 examples. Okay, so let me clean this. Okay, let me allow the board to be there first. We are going to convert a number. Today we are going to have conversion of numbers from other bases to base 10. After today's class, the next class will convert from base 10 to other bases. Is that right? So let us have this. Let's take this example. Example 1. We are going to convert 1 1 0 0 1 0 1 in base 2 to base 10. All right. So convert 1 1 0 0 1 0 1 in base 2 to base 10. So let's see that. Let's solve that together. Okay. So our solution. Okay. You bring the question down. You have 1 1 0 0 1 0 1 in base 2. We're going to take this to base 10. Okay. So this will be, I don't want to start it this way. Let me start it here. Okay. You have this one, the first digits multiplied by the base, which is 2. Raised to the power of the remaining digit, which is 1, 2, 3, 4, 5, 6, which is raised to the power 6, plus the second digit, which is also 1. Okay, 1, times the base, which is 2, raised to the power of the remaining digits after this one, after this. So that is 1, 2, 3, 4, 5. All right. And so we move over to 0. That is going to be plus 0 times 2 raised to the power of 4 plus the next 0, which is 0 times 2 raised to the power of 3 plus 1 plus 1 times 2, which is this 1 times the base raised to the power of the remaining digit, which is what? 2. And then plus 0 plus 0 times 2 raised to the power of 1 plus the last digit, which is what? 1. So that is 1 times 2 raised to the power of 0. Okay? So we are going to calculate that together. Okay? 2 raised to the power of 6, you will have 64 plus 2 raised to the power of 5, which is what? 32. Any number multiplied by 0 is 0. 0 times anything is 0. Then you come to this point. This is 2 raised to the power of 2. That's 4. The next one is 0 times any other number is 0, gone. Then you have 1 times 2 raised to the power of 0. That is the same thing as 1 times 1, because any integer raised to the power of 0 is 1. So that will be 1. This will mean 1 times 1. Okay? And that is 1 here. So if you add this together, 64 plus 32, that will be what? 96. 96 plus 5, that will be 101, 101. Okay? So that would be 101, 101 in base 10. That becomes the answer. Okay? So that's the answer to this. In converting 1100101 in base 2 to base 10, it becomes 101 in base 10. All right, let's take another example. We are going to do just 3 examples for today's class of converting numbers from other bases to base 10. Okay, so let me leave the definition for now. Okay, all right. Okay, we're going to convert 3154 in base 7. So example 2 says convert. Example 2 says convert 3154 in base 7 to base 10. All right. So convert 3154 in base 7 to a number in base 10. So let's solve this together. All right. Anytime you want to solve a question, you have to state your solution. State the space for your solution to be seen. All right. So here you have 3154 in base 7 to be converted to a number in base 10. So we are going to take the first digit, which is 3, and multiply by the base, which is 7, and then raise that to the power of the remaining digits, which is 1, 2, 3. Okay. Plus 1, which is the second digit, multiply by the base, and raise to the power of the remaining 2 digits. Okay. Plus the next digit is 5 times 7. Okay. Raise to the power of 1. Plus the last digit, which is 4, times the base, and then raise to the power of 0, because there is no other digit left. 4 is the last digit of that number. Okay. So now we are going to round that up. If you raise 7 to power 3, you are going to have 3. Okay, let's do that together. Okay. 7 raised to the power of 3 is the same thing as 7 times 7 times 7, which is 7 times 7 is 49. Then multiply by 7. Okay, 7 times 9 is 63. You keep 3. You carry 6. Okay, then 7 times 4, 28. 28 plus 6 will give you 34. Okay, so that becomes 343. And then that 343, the whole of what we are doing here is 7 raised to the power of 3. That is 343. Then multiply by 3 here now. That becomes 3 times 3, 9. 3 times 4, 12. Okay. 3, 3, 9. 3, 4, 12. You keep 2. And then you keep 2, carry 1. 3 times 3 now. Okay. 3 times 3 is 9 plus 1 that we carry. That becomes this. Okay. So the whole of this place becomes, the whole of that place becomes 1029. plus 7 raised to the power of 2, which is 49, plus 5 times 7 is 35, plus 7 raised to the power of 0 is 1, and then 1 times 4 is 4. Is that right? Okay. If you add this up together, you will have, let's add that up together. Okay, let's add that up. Let's start from here. You have 49 plus 35 plus 4. So this is 9 plus 9, 18. Keep 8, carry 1. All right. And then here is 7 plus the one you carry. That's 8. 88 now. Add it to 9201. So this and this is going to give you 7. Add this to this, 1, 1. Okay. So that becomes 1, 1, 1, 7 in base what? In base 10. Is that right? So in converting 3154 in base 7 to base 10, we have 1117 in base 10. Is that right? So I'm going to clean this other example to do the last example, okay? So let's do that together. All right. Okay. Let's solve that together. Okay. So please do well to hit the subscription button so that you can be notified anytime we have a video or we go live on this channel, or anytime we have a class, you will always be notified. Thank you for doing that. Let's have the last example. We are going to have this: convert 1101.111 in base 2 to base 10. Okay. The question says you should convert 1101.111 in base 2 to a number in base 10. So let's quickly have that. Let's get our solution. Okay. This, you have 1101.111 in base 2. We are going to take it to what? The base 10. So let's start. All right. Let me start it here. We start from here. You have 1 times the base, which is 2 raised to the power of 1, 2, 3. Okay. Plus 1 times the base again, which is 2 raised to the power of 2, plus 0 times 2 raised to the power of 1, plus 1 times 2 raised to the power of 0. This is the one. This last one is here. Why this is like this? Because this is the integer parts. From here to this side is the fractional parts, and that side is going to be operate differently. Okay. So plus, we have now entered into the fractional part. So here becomes 1 times 2 raised to the power of minus 1, plus the next digit, which is 1, also the fractional part, times 2 raised to the power of minus 2. Okay. Plus the last digit, which is 1. 1 times 2 raised to the power of minus 3. Those are the basis of operandi here. And then we are going to simplify everything together now. 1 times 2 raised to the power of 3. 2 raised to the power of 3 is 8. And then 2 raised to the power of 2 is 4. 0 times 2 raised to the power of 1 is 0. And then 2 raised to the power of 0 is 1. 1 times 1 is 1. Okay. We are done with the integer part, with the whole number parts. We are now going over to the fractional aspect. So 2 raised to the power of minus 1 is the same thing as 1 over 2. Then plus 2 raised to the power of minus 2 is the same thing as 1 over 4. And then 2 raised to the power of minus 3 is the same thing as 1 over 8. Okay. Then if you add the integer part, which is this one, you are going to have 18. Okay. Plus the fractional part. So that is going to be 13 plus 1 over 2 is 0.5. And then 1 over 4 is 0.25. And then 1 over 8 is 0.125. If you add this together, you're going to have, if you add all this together, you're going to have 13.875. invest 10. Okay, that is the answer for that problem. Okay, having watched this video up to this point, if you like the video, do well to share it to other people who might be in need of this video. Hit the subscription button so that you can be notified whenever we have a class or whenever we have a video. Could be live, could be a normal video. Thank you for watching, and bye for now.